This is the second half of 8.1, Sequences and Series. In today's lesson, you will use some summation notation to write the sums and find the sums of series, find the sums of infinite series. Okay, here we go. This is summation notation. This is the Greek letter sigma, which we're going to use for S or sum. Okay, when you see the symbol, that means you're going to add everything you see after it. And in this particular notation, on the bottom, it tells you that this is the index or whatever variable you'll be using in your formula or expression. And then what it equals to is the lower limit, where you're starting. And then what you put on top is what your upper limit is, where you're ending. So you're going to use all the numbers between 1 and 5, 1, 2, 3, 4, 5, to put it in here for the index, which is I. And you're going to add all 5 of those numbers together. Okay? So I is going to be, your index is I, and those values are going to go from the lower limit to the upper limit, going by 1. So 1, 2, 3, 4, and 5. Putting those numbers into your index or the variable, you add 4 to each one of these i's and then add those numbers together. So 1 plus 4 is 5, 2 plus 4 is 6, 3 plus 4 is 7, 4 plus 4 is 8, and 5 plus 4 is 9. And then the summation notation, the sigma, tells you to add all these numbers together, or this series of numbers together, and you get a total of 45. So the summation of the index I from 1 to 5 for I plus 4 is equal to 45. That's basically the whole lesson for today, except we're going to do some partial sums and some infinite sums. And this is from 0 to 3. Now you have to be careful when the lower limit and the upper limit, you have to make sure that you go through all the numbers. Now this one's going to start at 0 and it's going to end at 3, so you're going to have 4 numbers. 0, 1, 2, and 3 are 4 numbers. Okay, your index is k, and k is equal to 0, 1, 2, and 3, starting from your lower limit of 0 to your upper limit of 3. You can put all these numbers in for this index here, k, and then you're going to use the summation, meaning that you're going to add all those numbers together. So you can have 4 times 0, 4 times 1, 4 times 2, 4 times 3. You're going to add this series of numbers together, and you're going to get 24. All right. Find the sum of the series. So for part A, you're going to find the sum, the partial third sum. So third partial sum, that means you're going to find the first 3 numbers from 1 to 3 apparently. If it started at 0, you would find the first 3 partial sums, which would be 0, 1, and 2. If you start at 5, it would be 5, 6, and 7. So you just find the first 3, and you're going to count 3 numbers starting from the first, your lower limit. So in order to do this, we're going to go, this is my sigma notation. That's going to equal 3 over 10, 1, 3 over 10 to the second power, 3 over 10 to the third power. There's our third partial sum. And finishing this, we're going to get 3 over 10 plus 3 over 100 plus 3 over 1,000. Adding those together, this is easier to see in decimal notation. So if we write these as decimals, you can see that it's 0.333, and that's your answer. Okay, finding the infinite sum, you're going to go from 1 to infinity. So you're going to have to do all of these. So you're going to go 3 over 10 to the 1, 10 to the 2, 10 to the 3, and so on. All right, from 0.33 and then so on, which means that this is going to be 0.333 and so on. And you know that you can write that as 0.3 repeating. And if you remember from your Algebra 1 class that a repeating decimal is really over 9. So anything that repeats is over 9. Okay, and if you reduce this, you get 1/3. And some of you already know that 0.3 repeating is 1/3. Okay. And don't forget that in order for these infinite series to have a sum, they have to be decreasing. Each one has to be smaller than the last one. If they keep getting bigger, you can't find the sum because the sum would just be infinity because it's going to keep on growing. So it has to be shrinking towards some number, which is 1/3 in this case. And in the next problem, it will probably be shrinking towards another number, but it always has to shrink to some kind of number. Otherwise, you can't add all the pieces together. Okay. All right. So try these two. All right. So you're going to put 1, 2, and 3 in for I, and you're going to get 1, 2, 3. Nope, it's only the first 3. Okay, so you want the third partial sum, so you want the first 3. So it'll be 10 to the 1, 10 squared, which is 100, 10 cubed, which is 1,000. Writing these as decimals, you're going to get 0.444. Okay, now you're going to find the infinite sum. And going to infinity, if you keep adding these together, you'll see that it's 0.4 repeating. And if you, in case you forgot how you create a repeating decimal, is write it as a fraction over 9. So 0.5 repeating would be 5/9. So this is 0.4 repeating, so it'll be 4/9. You can try this out in the calculator. It's kind of fun sometimes. Figure out what maybe like 0.121212 would be. Try and figure that out. Okay. All right. Okay, writing the sigma notation. If you have a series, you're going to write the sigma notation. This can get kind of tricky, but if it's written out in a form which is easy, that helps a lot. First thing you're going to do is write the sigma. Then you're going to have your index. You have to figure out where it starts and where it ends. You have to figure out the expression that makes that. First thing you're going to do is look at each term and find out what's the same, what doesn't change. And it's 5 over 1 plus something every time. So I'm going to write that. And then I want to figure out what these numbers are going to be starting from 1 to a certain number. I can see that it starts, the part that's changing goes from 1 to 3 to 15. So this is kind of obvious that I starts, my lower limit's 1, the upper limit's 15. And all I have to do is put the I here, and that's my answer for this, writing this in sigma notation. Okay? All right. Using your TI, this is in the back of your textbook, and it tells you how to find the sigma notation. If you have a TI, then write this down. If you find the sum, you push second list math 5. Then you want to put the sequence in there, so second list op 5. And then you're going to put in the rest of your expression. So your expression, since your calculator is not too picky about the variable it uses, so you're not going to be able to put an I, just put in an N. When you push this X button, the XT theta N button, you automatically get an N once it's in this notation. Okay? So what you need to tell it is, what is the function? What is the expression that you want to find the sum of? And then tell it what variable you're going to use. So you put comma, and again, then comma, and then where you're going to start, the lower bound, or the lower limit's 1. what's the upper limit, which is 6. And then how do you want it to count by? You want to count by 1, so increment. And this is usually 1. And we rarely see examples like this where this is not 1. So this is how you enter it in your calculator. Now if you have a Casio, this is not in the back of your book, so you should write this down. These are the steps we're doing this. To enter sum on your calculator, you put options, and then list, and then arrow over twice, and you're going to find sum. Okay. Then to put the sequence part, you have to put a parentheses. It doesn't automatically put this parentheses in there. So you put a parentheses, and you arrow over, which is F6, and then you'll see sequence. And the sequence will give you a parentheses. Now you're going to put your expression in, 2x plus 1, and then you're going to use x for whatever index you have up there, whether it's I or k or n or whatever. And then the same thing here, you're going to have the lower limit, the upper limit, and then your increment, which is usually 1. So you need to have all that there. Okay, so that's it for this lesson. And let's see here. Make sure you do the Google form. This is number 1. Find the sum. This is number 2. Use the sigma notation to write the sum. So you have to write the sigma notation for this series. Okay. And then use sigma notation to write the sum. This is less obvious. The other one's written out for you. This one's less obvious. And then find the 5th partial sum, like I just showed you before. Okay. And number 5, find the sum of the infinite series. Find it all the way to the end. All right. And then the last one, what is the upper limit for this sigma notation? That's it.